Farjana Bhuiyan, a senior biomedical engineering student at the University of Texas at Arlington, and today I'm going to talk about my project, NEXTGEN ECGs. This is an active suction cup supported ECG electrode system inspired by octopus tentacle, and it's going to change the way we measure your ECGs. For this paper, the co-authors are Madeline and Dr. Bhuiyan. As of background, approximately 300 million ECG tests are performed worldwide annually. 10 million stress tests are performed in the United States every year on average. Here you can see an traditional ECG electrode pads, which are basically adhesive stickers that are going to stick to your skin, and then a metal electrode in the middle to take the reading for the heart's electrical activity, and then a halter setup, which is basically using the same traditional ECG electrode, but this setup you have to have on your skin with constant contact for at least a day. The problem over here is the detachment of electrodes that happens even with the slightest physical movement. Last summer, I had the privilege to be a part of the clinical immersion program where I had the opportunity to observe it myself, how even with the slightest movement, the electrodes come off, and then that means that you would need to redo the whole process again and again, and it takes a lot of time to perform the ECGs. And not to mention, if you have hair on your chest, you just got yourself a free chest wax. But it's very difficult for people who have oily skin or sweat on their skin. Over here we have a volunteer to mimic or demonstrate the stress ECGs with these traditional adhesive electrodes that are available in the market. Here you can see that in the very few seconds this traditional ECG pads would come off when the person is running on a treadmill. For stress ECGs, the whole process takes about 20 minutes, and for the whole 20 minutes, on an average, we need the electrode pads to stay in contact with the skin. Now, for this, the solution we come up with is developing a suction cup based design. This is the cross-section of the suction cup where we tried to create a travel distance on a crumpled zone. Here you can see the neck is made a little thinner than the base, so when you pull a suction, it crumples, creating a sealed contact with the skin. After this suction cup is 3D printed, we made a negative mold and then a positive mold out of it. The positive mold is biocompatible silicon, Dragon Skin 20, and the negative we used was Compact 45. This is the whole exploded view. This suction cup array is supposed to be attached with a vacuum chamber, and then to put pressure on the suction cup area, we will have an outer ring, an inner ring, and the metal electrode will be placed in the middle. This whole system, it's gonna be screwed with metal screws, washers, and nuts to create a seal system. This is what the assembled device looks like. For the very first time when we were building this prototype, we first made the suction cup array and tried to pull out suction from each cup itself to see if the design on the dimensions of the cup works to what we expect it to be. And then this is some of the few times we tried to pull it out on glass, on skin. This was quite what we expected, but the problem we were facing was having it crumple onto itself, which kind of breaks the seal system. So we changed the dimensions a little bit to make the walls a little thicker, and this is what we have as our latest iteration. This is how the suction cups work, and this is exactly what we have expected it to be. And then we tried to use it with the vacuum chamber. Here you can see that vacuum is being pulled out of the suction cups, but it still is not enough, which we believe is due to mainly because of having the vacuum chamber made up of ABS, which itself is a very porous material and doesn't do too good of a sealing. Apart from having more sealed chamber using resin or any other material which is less porous, our greater vision is to have a smaller device which is similar to the ones in the market in terms of dimensions. Our current device is 60 millimeter, but we intend it to be 30 millimeter, and that will increase its anatomical accuracy as well. But in general, our device is gonna be reusable, which is gonna help you save money, and then you will be able to perform more ECGs in a shorter period of time. That also means that you will be able to address more patients when compared to the traditional ECG electrode pads, and not to mention it enhances user comfort. That's pretty much it. Thank you for listening, and I hope next time you go to an ECG session you have a seamless experience.